and with me early on, and that will make your life easier. So stop by and say hi. And in all of this, we can all commit to being both skeptical, where we want to ask questions, respectful of others, curious, and playful. Okay, today's talk is about the context globally of the Sustainable Development Goals and the goal of providing everyone with access to safe water. The importance of having safe water on tap, and how not having safe water on tap ends up being a spiral to failure. And as another example of that, what happens when you have a water supply system that is intermittent, where you only get water some of the time, and how that is one of the potential spirals to failure. I'll talk a little bit about the myth that the technology is well developed, and end with a role for universities. And then if I pull this off, we'll have plenty of time to land in the office, in the Gather office, and we'll have some questions, some things to do to make sure that it's easy for you to report problems about this class when you encounter them. So first, Sustainable Development Goals. Here they are. There's 17 of them. The goal is to have this all wrapped up by 2030. I think there's the planet is good at making these really wonderful goals, but actually implementing them is much, much more difficult. The one that we're focused on is clean water and sanitation. The goal is to achieve universal and equitable access to safe and affordable drinking water for everyone by 2030. And on the sanitation side, support and strengthen the participation of local communities in improving water and sanitation management. Sorry, that's both on the sanitation and the water side. And those are things that we can get excited about, like where it's absolutely right that local communities need to be fully engaged in managing their infrastructure. And we certainly would like everyone to have access to safe drinking water. And in this course, we sometimes shorten it. We would like everyone to have SWOT, S-W-O-T. We would like everyone to have safe water on tap. So here's some facts about where this is at. So as of 2015, and I know this is old data, but I went and looked, and there's, the data is old, and oh my, the data is old, and the data is not as great as you wish it would be. In 2015, 71% of the global population, or 5.2 billion people, used a safely managed drinking water service, meaning something that was located on their premises, like a tap or maybe a pump or a well. It was available when needed and free from contamination. So that's a statement from the World Health Organization, and let's bring some skepticism to that claim. And part of the skepticism is that that statement was made without collecting data on water quality in rural areas. So we don't actually know nearly enough to make any claims like is made in that first sentence there. And I contend that this estimate of 71% having access to safely managed water it's not nearly as good as what they would have us believe. So here's some more data from a UN fact sheet. Here it says 90% of the global population used at least a basic service. And a basic service is an improved drinking water source within a round trip of 30 minutes to collect water. So you only have to walk at most 30 minutes to bring back improved water. And then another statement, 884 million people lack even this. And that includes 159 million people who are dependent on surface water. So that means there are 159 million people who have to walk more than 30 minutes to get surface water that is almost certainly extremely contaminated. And then here's another statement, and I'll see if you're really paying attention, it'll start raising some questions. globally, at least 2 billion people use a drinking water source that's contaminated with feces. And if you put statement 1 and statement 2 together, you know what you get? You put those two statements together, 90% of the population has access to an improved drinking water source. 2 billion are drinking water that's contaminated with feces. And the only way that the math can work out, given the global population, is that there are some people that are using what is considered an improved drinking water source, and it's contaminated with feces. So even our definition of what an improved drinking water source is probably pretty bad if it includes drinking water that is contaminated with feces. And we know contaminated water can transmit diseases such as diarrhea, cholera, dysentery, typhoid, and polio. And it's estimated to cause 500,000 diarrheal deaths each year, which I guess is not as bad as what COVID has done to the planet, but this is happening every year, all the time. A few stats from Honduras, because that's where I like to play, where I have lovely contacts. Again, from the World Health Organization. There, the claim is that 97% of the urban population has access to an improved water source, and 83% or 84% has access in rural areas. And when I travel around Honduras, I'm like, where are these 84% of rural areas that have access to improved water? And so you have to be really skeptical of language. In this case, improved water source included water that was in a pipe. So water that was in a pipe was by definition improved. And I'm hoping that you're thinking that putting river water in a pipe doesn't make it safe to drink. And so improved water isn't necessarily safe. So it shouldn't have been our goal. So that's an example of improved water, because that water was going to go into a pipe next and come out of somebody's tap. That's not what any of us want as our drinking water source. And then here's another example of something that was definitely improved. This was a surface water source that was going into a distribution tank for a large town or city. And there was a tank of chlorine sitting on top of it. And there was a little valve put in the bottom of that tank, and it was dripping chlorine into the tank. And that was the extent of the water treatment. So this is at least one step up. They were doing one thing to their water before it was distributed. To be fair, this picture is probably about 15 years old, and that situation has been remedied for that city. But there are many, many, many towns on this planet where water treatment is either non-existent or inadequate. So billions need safe water on tap, and the question is, how many really? So here's some estimates. About 2.3 billion lack access to safe and readily available water at home. And I put my little caveat in, this is Monroe's parentheses, where I'm like, yeah, we don't actually know that number, and maybe it's actually a whole lot higher than that, based on the fact that it's very easy to tell that the numbers have been way inflated for how good things are. So let's take 2.3 billion. And then over the next few years, we're going to have an additional 1.2 billion in population because of growth. And that gives us 3.5 billion that will need treated water by 2030. And if you turn that into, and I'm realizing I should have updated these numbers. These numbers were from a couple years ago. And so the math might not work out if you use 2022 as your date. But it takes something close to 267 million people per year. And it's as if we were building water supplies for 18 New York cities per year. That's what it would take to meet this huge pent-up need and the need that's coming online as more and more people are being born, as the population is growing. And so now I'm Okay, I started out at 2.3 billion, I think, and then I got up to 3.5 billion. And then there's another thing that we should take into account, and that is that the water supply systems, including the treatment systems, have a limited life. And so the ones that have already been built, those need to be repaired eventually and replaced or upgraded. And so if we assume a 50-year lifetime, and now we got 8 years left until 2030, that means that 16% of existing plants need to be replaced, and supposedly 5.6 billion have safe water on tap. That's based on the total population minus the number that don't have safe water. And so I get another almost billion people that would need an upgraded system by 2030. So I suppose if you're thinking, yesterday I was trying to convince you that you should become a business major, right? Remember? Now I'm like taking the other side and saying, but if you look at how much work is left to be done on providing safe water, it is one pile of work where the numbers are in the many billions. Here I come up with a total of 4.4 billion people who will need either new water treatment systems or new water supply systems or upgraded ones by the time we get to 2030, if we're to meet our goals. And there's my Monroe's statement on the right, which is not based on any data. I want to be very clear. This is just Monroe making an opinion and wishing that someone would prove me wrong. Okay, so I'd happily be proven wrong in this, but my bet is that the amount of infrastructure needed and not yet built to deliver safe water on tap to everyone on the planet is greater now than at any prior time in human history. It's because population has been growing so fast and we've been doing such a poor job of meeting everyone's needs. I think the deficit of that infrastructure is greater now than ever. Happily proven wrong. Okay, the value of safe water. So here's a graphic that gives some ideas about how much it costs to provide water various ways. So let's start all the way over at the right. You can have individuals in their houses collect some transparent soda bottles or water bottles, and they can put contaminated water in those bottles, and then they can set those bottles on the roof of their house, and they will get hit by sunlight, and the sunlight has UV light that ends up acting as a disinfectant. And so you can disinfect water that way. You can chlorinate the water in your house. You can have a little bottle of Clorox with a little dripper on the end. And so you can drip chlorine into the water that you're going to use in your household, and you can treat it that way. Or you can boil the water, or you could run it through a ceramic filter and have the water treated that way. And then getting into like more centralized approaches, you can buy water, and there's a couple different ways that you could buy water. One is you could buy bottled water, and another one is you could have a tanker truck come to your house and bring water to your house. Have any of you been anywhere where you've seen tanker trucks roving the streets providing water to homes? I see at least one of you has seen that. There are many, unfortunately, there are many cities on the planet where that is the dominant way of getting water to households in the city. And then the last one, the one that requires the least effort at the household level and that presumably costs the most, is centralized water treatment, safe water on tap. And this is a graphic made by someone else, and I want to just like push back a little bit on this notion that centralized water treatment is actually more expensive than vended water. And I want to push back on that because it is common for communities with poor water service to pay more for water than for the communities that have excellent service. Very, very common. And if you're buying vended water where a truck is bringing it to your house, or you are buying bottled water from a local store, you are paying far more for water than you would if you had safe water on tap coming to your house. I can talk about, like in my house, my water bill combined water and sewer is $30 a month. So I pay $1 per day for all the water coming into my house and then all the sewage going out of the house and being treated. If I were buying bottled water, I would easily exceed that price just with bottled water for myself. Having an excellent safe water on tap system is actually not so expensive. There's another thing to think about, and that is all this water, the water that people might use in their homes and run it through a filter or boil it or chlorinate it or disinfect it on the roof. Where did they get that water? I always joke that I know how to treat water, but I don't know how to make water. So that water had to come from somewhere, and either they had to walk out of the town or city to get it, or there was a pipe system in the city that was delivering them water, but it wasn't clean enough to drink. So that's interesting. If you're getting water to your house and then you're boiling it in your house because it's coming to your house dirty, that is what I call a cycle to failure or a spiral to failure. And I want to drive home a point about the relative cost of delivering water to your house versus the cost of treating the water. And we'll do this just by looking at Google Earth. So this is a town in Honduras. It's got about 3,000 people in it. It's Moroseli. And let's see, and Patrick has been there. And Moroseli has a water treatment plant, and you can see it under the little red dot there, except that you can't see it because it's covered up by the little red dot. So we zoom in a little bit and you still can barely see it, but it's right there. There's a tiny little building. That's the water treatment plant, okay? But then zoom back out again and look at this picture of the town and realize that every street in that town has a pipe running down the street, and there's pipes going into each house. And the question is, does it cost more to build the pipe network, that the distribution system that delivers water to each house, or does it cost more to build the water treatment plant? And just by looking at the scale of the problem, you should be getting, like, your engineering intuition should be kicking in, and you should be saying, wait a second, there are like miles and miles and miles of pipes. And then there's this one little building that's got stuff in it that's treating the water. And what I didn't show you is there's probably something like, I don't know, 15 kilometers of 6-inch galvanized iron pipe that's running from this town over to the river that they get their water from. So the point here is that that providing water on tap costs a whole lot. Treating it costs a little bit extra. I bet before you thought that treating it was the expensive thing. Or maybe you never thought about it. But the insight is treating it is actually not very expensive. And that changes how you think about everything. Because if treating it isn't that expensive, then you have to think about this like you're running a business, and you want to make sure that your business is sustainable, and your business is, you are the water utility for a town. And you have an option. You can either provide your customers with river water that's untreated, or you can spend a little bit more and get a treatment plant, and then you can provide them with high quality drinking water. Which business model is going to be more successful? And to think about that, you need to think about how much people are willing to pay relative to how much it costs for you to provide that service. And the key here is that people are willing to pay a whole lot more once you go from dirty water to clean water than what they were from going from no water to dirty water. So people really want water in their houses at all costs. But but they still are low. They don't want to pay a whole lot for dirty water. It's really hard to like get up your excitement about paying a water bill for muddy water. But once you have clean water, you're willing to pay a lot more. And there's also this whole sense of pride that comes of, hey, I live in a town where we have high quality water and my kids are feeling good. And I'm not like those other towns close by where they have crappy, dirty water coming out of their taps. So there's pride and there's willingness to pay for it. And that makes the entire water supply system so much more sustainable, because now the community, the water board or the water utility is able to charge more for their services than what they actually cost. So they can run a surplus, and then they can use that surplus to keep on improving their water supply system. And we have seen this multiple times in Honduras, where once a community gets a water treatment system, they take steps to improve other parts of their water treatment system, because now they're able to generate the revenue because people are willing to pay more for that water. So in this graphic, we start out with first dirty water here at the bottom, number one. It actually costs a good deal to provide dirty water, but people aren't willing to pay for it. So it's in that lower quadrant of this graph, and it's below the solid line at 45 degrees that represents they're paying enough to actually make it viable. And then if you add treatment, and you add treatment where it doesn't perform super well and it's expensive to run, then because it's expensive to run because maybe of energy costs, that's number two. So you've built a water treatment plant that it costs a lot to make the water safe enough to drink. And so that might also be unsustainable. So the goal is to somehow design a system that gets you above that 45-degree line. And the way you do that is by making a water treatment system that is more cost effective, it's more efficient, and it has lower operating costs, and it still has high performance. And so by doing that, you can get above this, people are willing to pay to support the plant line, and you get to success. So everything below the line is a spiral to failure. Everything above the line has a potential to succeed. And there's this spiral to failure. If you can't get enough money to support the infrastructure that you have, then as that infrastructure begins to fail, you don't have the ability to repair it. And so your service gets worse and worse and worse. If on the other hand, your system has run with enough income so that it's actually succeeding and can sustain itself with a little bit of extra, then you can keep on improving your service and the system is a success. Wow. I got excited about that because like this is a key insight. Communities are willing to pay for safe water in many, many cases, and it revolutionizes what happens in those communities. And we have to think about the economics of this. We have to make plants that are low cost, both to build and to maintain, and have low operating costs as well. So we got that. So the conclusions from that, there's a misperception that centralized water treatment systems are a bad idea. I didn't talk about this, but like I hear this, maybe I'm trying to figure out where I hear this. I think academia is one of the places where this idea comes out. There's this notion that centralized is just a bad thing. And I fight back and say, wait, are roads and bridges and hospitals and trains also a bad idea? Like, do we not like anything that's centralized? And I'd argue that as a civilization, there are many things that the only way to do it well is to do it centralized. It has to be done by a community, by a group of people working together. The capital cost of delivering water on tap exceeds the capital cost of treating the water by perhaps a factor of 10. So that's why adding the treatment on top of delivering the water ends up being a really good business model. And in order to be financially sustainable, drinking water suppliers must provide a service that is highly valued by their clients, by their customers. Okay, now we're going to talk about failure. Intermittent supplies, the spiral to failure. So it's estimated that over 1/3 of the urban water supply systems in Africa and in Latin America and the Caribbean, and more than half of those in Asia operate intermittently, meaning that if you go turn on the tap, you may well get nothing. And then maybe there's a certain time of day when the water comes on, or maybe it comes on every couple days, or maybe it comes on once a week. And I'm curious, I'd love to see a show of hands. How many of you have been in a place where you've had to deal with intermittent supplies? Who's lived in a place where the water supply was on and off? Wow. How about, did anybody visit a place that was like that? Okay, so there's been a visit. So this is a reality that we are so fortunate to not have a lot of experience with, but a lot of people on the planet, this is a daily reality. And you can imagine for whoever is running the household, this often ends up hitting women worse, and also children and girls worse. This is a daily reality of having to do things to like store water, manage water, and sometimes deal with having severe water shortages in the houses. So why does this happen? So this is like a rolling blackout. This is like an electrical grid where there's not enough electricity, and so they turn off Columbus for a while so that the rest of Ohio can have electricity. So it's a crude form of rationing. It often, not always, but it often is correlated with systems or associated with water supply systems where they don't have meters. So this is a whole other topic, but in my house, there's a water meter, and it is read actually electronically by the water utility, and they charge me for the water that I use. I like that system because that means that if I save water, I pay less for my bill. Okay, with a caveat that in my case, I use less water than their minimum, and so it doesn't matter. But anyway, it should work that ideally if you use less water, you would pay less when you're paying with a metered system. In many cities, and especially rural towns, there aren't any meters. And so when you are connected to the water supply system, you're basically paying a monthly fee that is like your access to water. You have access to the network, and no one's keeping track of how much water you're using. And that means you don't have a personal incentive to save water. And in those systems, you can just guess that in those systems, if you walk in and inspect the toilets, that a very high fraction of the toilets are leaking, and it just wasn't worth anyone's time to fix them because they weren't getting billed for it. Whereas in my neighborhood, if your toilet leaks, it causes a ruckus because your water bill goes up, and you realize you should have spent $10 to fix the toilet, or $20 instead of the couple $100 that you're paying for all the water you're flushing down the drain. So lack of meters people don't tend to conserve water when they don't have water meters. And so then the way to ration the water is just to turn it off to everybody on a daily basis, or maybe or other cycles. Another reason why a water supplier may decide to turn off the system intermittently is because the system might have leaks in it. And so they can reduce how much water they are losing to leaks by turning off the water to the system part of the time. So another failure mode. Here's another problem. Maybe the system, maybe the population of the city has continued to grow. And in many places, when cities grow, if they're in mountainous areas, people are moving up higher and higher into the mountains, higher and higher elevation, and the water supply system has trouble getting the water up to those new higher neighborhoods. And so they might turn off water to other neighborhoods so that there's more pressure in the distribution system so that it can reach those higher neighborhoods. So those are the elevation challenges. So we've asked that question. Let's see. I'd like you to think about this, and I think we can do this by having you go into breakout rooms with about 3 people in a room, and I'll give you the context, and I will attempt to I learned how we have to do this. I have to send you the questions in the chat before we actually get there. So I will figure out how to do that. And here that comes. So here are the questions. Whoa. So first one, we'll answer this one together before we go out. And then the one that I want you to think about is water is intermittent, what you do. But first, before we break up, what do you do if electricity is intermittent? So you pretend you've just bought this hotel in Delhi, in India, and you're a business person, and you realize that in Delhi, the electricity goes on and off. So what do you do? Anyone, just pop in. What do you do if electricity goes on and off, and you've got a hotel, and you've got people who need to have air conditioning in your hotel?
You would buy like a generator or something as a backup.
Exactly. And so believe me, the hotels in Delhi have generators. Okay. So, okay, we got that problem solved. Now, water is also intermittent. So what do you do? So think about that, and I will pop this question into the chat if I can figure out where to do this. Okay, so we'll do this here. So think about how do you get more water, and think about, for the various methods that you come up with, think about how they might affect your clients in the hotel by affecting the water quality that you're providing them. And let's spend 5 minutes. So come back in 5 minutes, and I'm eager to hear what you've figured out.
I'm just gonna chill here, not join a breakout room with the students.
Is everyone back? I'm going to assume so. I'm curious to hear what you came up with. And I hope you had fun thinking about this, because this is not just like real life. This is real life for many people. So you can just call out an option that you came up with for how you might get more water. Go for it. How might you get more water?
Rainwater harvesting.
Excellent. Rainwater harvesting. You'd put spoutings on your, collect the water off your roof. Okay. What else would you do?
You can just store water when you do have it for later.
Okay. And do you know what that looks like in a hotel? Do you know what they do?
Put it in a big tank.
Yeah, and you may have seen this in some cities, the skyline.
On the roof, probably.
Exactly. Good job. There are many cities where if you look at the skyline, you're like, oh, there's a tank on every single building in this city. What else could you do?
You could get a water tanker to come in and bring you water.
Excellent. Sure, you could pay a water tanker and they would happily come and fill up the tank that you have on your roof. Good. Any other ideas? What you could do? You're in a city, you need water really badly.
If it were economically feasible, like having your own like small water treatment system in your building, and if you had enough electricity, just essentially pump it from the river yourself.
Okay, so this is great. So you could like recreate the system and bring water from the river, but let's just assume that you're in the city and there's just no way to get water from the river. Because most likely that's a pretty tough one. So what else could you do to get water close by?
Would a well be an option?
A well is an excellent option, except it's a really bad option. It's an excellent option, Mackenzie, but it's an awful option. Do you know why wells are often a bad option in cities? It's because in cities, there's an awful lot of people living there doing an awful lot of different things. And there's a very high probability that the groundwater is contaminated. We've been through this on multiple cities where initially residents start out by everybody drills their own well, and then it doesn't work out well. So that was actually getting to, that's a potential bad water quality. And I want to go, I want to follow up. Who had the idea of the tank? Was that Dan? The idea of you're going to pump the water and fill up a tank on the roof, right? Or store it on the roof. Okay. So you can take that idea one step further, and you can say, since I'm gonna pump the water up to the roof of my hotel anyway, why don't I'll use that pump and I'll actually suck water out of the distribution system. So even though there's no pressure in the distribution system, I'll pull whatever water is left and pump it into my tank up in the roof. So if you connect the pump to the distribution system and you suck on it until you start pulling air, you'll be able to pull water out of there, and you've got it. That's golden, except it has some very nasty consequences. And that is that when you were pumping from the distribution system to fill your tank, you were decreasing the pressure in the distribution system. And that's the next story. I think, if I remember what's next in my notes, and that is that you can have contamination of your distribution system because pipes leak eventually. And since many distribution systems are old, there's leaks, and even a brand new system can have some small leaks. So think about this, like right outside, wherever you're hanging out in Columbus right now, outside the dorm or wherever you're at, there's a street. Going down that street, there's a line of fire hydrants, down the street. There's a pipe from the Columbus Water Authority, or whatever their official name is, that's delivering water to that building. And what else is also running down that street underground, in addition to that lovely water pipe?
Sewage.
There's a sewage pipe. Okay. So now how do you feel about the fact that you're drinking water that's coming from a pipe, and somewhere, several feet away, there's a sewage pipe? Nobody's going to drink any water again. Okay, but why is it okay? It's okay because the sewage pipe is not under pressure. And so if there's, so the sewage pipe is not under pressure, which is nice, because you can think about bad things of sewage pipes under pressure. But the drinking water pipe is under pressure. And that means that if there's a leak in the sewer pipe, and there most certainly is, and there's sewage leaking out, even if it contaminates the ground all around your water distribution pipe, the water distribution pipe is under very high positive pressure. Any leaks, water's coming out, not going in. And so I still will happily drink that water from that distribution pipe. Okay? But let's go back to Delhi. Now you as a business owner are deciding that you're going to connect a pump to the distribution system. And when they turn off water to your sector of the city, you're just going to keep on pumping until there's no more water in that distribution system. And so you're going to lower the pressure in that distribution system. And now sewage that's under the streets can be flowing into that pipe, and the water in that pipe network is completely contaminated. So that's like the story of why intermittent supplies leads to a chain of events that goes really, really bad, which is why here we try really, really hard. It's required that we provide water 24/7, and why it would be great if we could have that happen everywhere on the planet. And I know that that's a big dream, but that would be my dream to be pushing towards for all of those reasons. I think I don't need to go into more detail on that. Here's another option. Okay, look, let's just give up. The water coming from centralized systems, there's a water treatment plant, and then there's this pipe network, and the water is going to get contaminated in that pipe network because there's always leaks, and because we can't afford to provide water all the time, there's intermittency, and so the pressure is getting lowered in the water distribution system, and that means it's contaminated. So let's just not worry about sending safe water to people with centralized systems because we can't get it. We can't achieve it. And instead, everyone is going to install in their homes a point of use treatment system, and they're going to treat their own water. What do you think about that? How do you feel about that option? Like it is the like the independent streak. I'm going to do it myself. I'm going to be in charge of my own destiny, and I'm going to treat my own water. And you can think about it like, think about your hometown. How would you feel if in your hometown, they decided that, you know what, centralized treatment doesn't make sense. Let's just have everybody clean up the water themselves. Any emotions you want to share? Or things that might go wrong?
I mean, I don't like the idea that the water is completely untreated and totally filthy right up until it hits my house. And then I have one line of defense to filter it before it goes through. If anything goes wrong, it's on me, right? Like nobody else is going to care.
Right.
It's just my house that has dirty water now.
Yes.
Also sounds just very costly to the homeowner. I'd wonder if it would be like subsidized by the city government or something like that, hopefully. But
No,
yeah.
they'll lower your taxes, or you won't have to pay the water bill anymore. So you won't have to pay you won't have to pay, like, what did I say? I said I pay $1 a day. So they'd only charge you 50 cents a day now, because they still have to treat the sewage.
I was gonna say, like, you talked about distribution earlier, like that infrastructure is already in place, and like we were thinking like that was the most costly, that like a centralized water sanitation place like wouldn't cost that much more.
Yeah, thank you. You were listening. If we rely on household level treatment, do you have any sense of who might end up not coming out of this being very healthy?
People who can't afford to have a whole home water treatment system installed.
Exactly. So now the people who have fewer resources or less time to manage that system, or who have a child who goes and grabs something from the sink where it wasn't treated yet, or maybe they, will they treat everything that comes into the house, or will they like only treat the water that they're going to drink? You can save a lot of money by only treating the water you're going to drink, but then it means that if your child, takes a sip while they're in the bath, you're done. You can guess what my opinion is on all of this. I'm a pretty strong advocate of engineers. One of the things that we can do is we can design infrastructure that makes it possible for communities to thrive. And what we would like to have is communities that can thrive. And one of the important ingredients is having access to safe water. It improves everyone's quality of life a lot. Okay, I don't want to spend more than 5 more minutes on this. So technology is well developed. Just this myth. Well, thank you. I forgot about that. I was enjoying looking at you guys. So back there you go. And thank you. And you all know, I told you that I was going to make mistakes, right? I promised you I would make mistakes. And I welcome feedback. So don't feel shy. Okay, so this is this idea that, we already have the technologies that we need. What we need is the political will and institutional capacity and education. And with that, we can solve the world's problems. And I just had this reflection. This statement was made back in 2005, and that was before electric cars. And it means that this view is saying that we don't need new technologies. And I hope you feel like this is really bogus, right? There are still opportunities to invent better technologies that will make a huge difference for human sustainability on the planet. And we shouldn't just assume that the engineering is done. It's almost funny how that idea that like there was ideas that we would close the patent office 100 years ago because everything had been invented. And those notions just never made any sense. We will continue discovering things, and there's a chance of discovering things that will make a huge difference for the welfare of humans. So I like the word "and," that we need both good policies, good education, good institutions, and we need good technologies. And the thing that I'm skilled at working at, and you are learning how to do as well, is develop better technologies. And when you develop a better technology, you can perhaps help compensate for the fact that a community doesn't have access to a whole lot of money by implementing a technology that is more cost effective. And so yes, a wealthy community can have a crappy technology and they can maintain it and keep it running because they have a lot of resources, economic resources, to keep it running. But a poor community actually needs a better technology that is more cost effective. And so an engineer can help bridge that gap. So we need all of these things. And here's the multiplication. You need ones everywhere, or at least a number that's not 0 everywhere, in order to get to success. And if you have really, really crappy technology, it's not going to work. If you have excellent technology that is really, really cost effective, the community can be poorer and can still make it work, and you can still get that one of success. Just a few fun photos, some package plants in Honduras, and pointing out, oops, my box mixed, but you can see there's motors hanging out there. Here's some more motors. And the reason that there's a pump here is because when they designed this, they said, put these 2 parts of the plant on a level spot. And so because it was on a level spot, they needed to pump the water from one section to the next. And so that pump runs day and night and uses a ton of electricity. And all they would have had to do is locate the second, the filters just a little bit lower, a few meters lower in elevation, and then it would have worked by gravity and they would have eliminated that pumping cost. So we can use our brains and figure out how to make systems that are more energy efficient. And then this is about designing for the operator. It's like, why did the operators need to build this ladder and need to use it to get access to the plant here? And the reason is because they didn't have adequate access to that tank from the ground level. And that's what they needed. So, and here's another one. This, believe it or not, I mean, you can see the person there grabbing hold of this handle. That is the access port into the bottom of a sedimentation tank. And the reason that that access port is important is because that's where you have to go to clean out the sedimentation tank when it doesn't clean out properly. And so what you have to do is grease yourself up and slide through that hole to get into the tank. And I would argue that is not designed with the operator in mind. We should do better than having that sort of an access port to clean out a tank. And last, a role for universities. You're going to develop new knowledge. I think I'm just going to go to this. It's this whole idea that you do laboratory research, we design new technologies, we work with partners who build new infrastructure, and then ultimately people get safe water on tap. And there's this circle, and the university plays a key role in developing those new technologies and helping to create those designs. And with that, we can go to, we're going to this. I'd like to ask how playing with Onshape is going, but you're shy. So what I want to do is I want to all jump into the Aberclada office. And I have a question. Does anybody not know how to get to the Aberclada office? I want you all to get there. You've got the link in the email. I could pop it. I'm going to stop this. Okay.
While you're doing that, Monroe, I'm going to send to the chat the link for office hour availability. Some of you have filled it out, but not all of you. So please, if you can fill that out, it will help us schedule those accordingly.
Okay, so there's the link to the office, and there is the password. Jump in there, and what I'd like you to do is go into one of the 9 tables where there's green and there's red and there's yellow chairs, and form a team of 3 people or 4 people. And then I will broadcast a challenge for you to do in there. Okay, so see you there. I'll see you on the other side. Bye.
I'm gonna head out. Thanks. It was good to see you.